Southern Illinois University's Aquaculture Research Lab and Illinois-Indiana Sea Grant presents the Larval Yellow Perch Culture Video Guide. Module 4, Larval Rearing Tanks. Larval rearing tanks can be set up as flow-through or recirculating systems. Tank size may vary depending on what equipment you have access to, production goals, and how long you plan to use the system prior to moving fry or fingerlings to larger tanks or outdoors to a pond. At SIU's Aquaculture Research Lab, larval yellow perch are reared in recirculating systems. Recirculating systems are systems that filter and recirculate 90% or more of their system water per day. Here you see the water enters a 74-gallon rearing tank through an inflow pipe. Inflow pipes should have 1/8 inch diameter holes drilled on one side along its length, spaced approximately 2 inches apart from one another. This allows water to flow evenly through the whole depth of the tank and creates a light current. Inflow pipes have an outside diameter of 7/8 inches, should extend to the bottom of the tank, and are capped at the bottom. They are not glued in place, which allows for them to be turned to manage flow and rotation conditions. SIU uses intake standpipes and center drains to manage outflow and set water depth. Larval rearing tanks require screens to be placed between the culture water and drains to prevent larval escape. This is done by placing a large diameter skeletalized and screen-covered pipe over the standpipe. A variety of different mesh-sized screens are needed for larval yellow perch rearing. We start with the finest screens and change them out as larvae grow. Center screens and other types of drain screens are used to prevent larvae from being sucked down the drain and escapes, while allowing enough water to move through the tank to keep the tank's inflow and outflow balanced. Specifically, during live feed stages, SIU uses a special dual screen standpipe cover. The lower screen, 0.5 millimeter, accounts for the water column depth below the surface, while a slightly larger 1 millimeter screen at above the waterline surface allows the passage of surface oils. Around the time of complete dry diet transition, the standpipe cover screen size should be increased to 1.5 millimeter. It is recommended to have one set of each screen size, plus a minimum of one extra. When removing screens, you will want to remove the dirty screen, replace it quickly and gently with a clean screen, and then clean the dirty screen. Each larval rearing tank is fitted with 2 nozzles to spray system water onto the surface water to better allow larval gulping of air. Position one at 90 degrees and the other at 45, making sure that the 45-degree nozzle is pointed in the same direction as water flow from the inlet pipe. If using larger tanks, you may need to increase the number of nozzles. Keep tanks under constant low light conditions. Light conditions should be maintained between 100 and 200 lux. Dimmer switches can be used to gradually increase light intensity for feeding and cleaning. If necessary, hang black tarps over the entire system to separate it from the main room lighting, and attach a set of strip lights within the tent. Before stocking larval rearing tanks, the system needs to be cleaned, filled, and ran to make sure that the system is operating properly and the water conditions are safe for larvae. Thoroughly clean all tanks, tank parts, and equipment to be used in the tanks. Watch Module 1, Cleaning and Disinfection, to review the 5 steps of effective cleaning and disinfection. If using municipal city water, pre-treat water with sodium thiosulfate to remove any chlorine. In a separate container, combine water and sodium thiosulfate and aerate. The sodium thiosulfate water mixture and precipitate within should be mixed prior to being added to the system. A peristaltic pump is used to pump the sodium thiosulfate mixture from the separate container into the system sump or into a tank of makeup water to be gradually added to the system. Exact amount of sodium thiosulfate to be added to the container will depend on chlorine content of the water and the size of the system. Generally, 2 to 7 parts sodium thiosulfate to neutralize 1 part chlorine is recommended. Fill the larval rearing system with treated water. Attach water inflow pipes to inlet. The water inflow pipe should be the length of the tank height and run vertically down into the water of the tank. Once attached to the inlet, water will flow evenly through the whole depth of the tank, creating a light current. Set the system flow rate between 1.8 to 2 liters per minute. Flow rates will not be kept constant as the larvae grow. The flow rate will be gradually increased as larvae grow and become more active swimmers. There should be a current that induces swimming action, but not so fast that it is strenuous for the larvae. Run the system for a minimum of 24 hours to make sure that it is balanced and everything is operating properly. Check and adjust flow rates and water quality parameters before stocking with larval fish. Larvae being moved directly from an egg incubation system may be at a lower temperature. Adjust larval rearing system temperature to match the egg incubation temperature and gradually increase after larvae have been stopped. The rule of thumb used at SIU's Aquaculture Research Lab is to increase the water temperature gradually 2 degrees Celsius every day. That is equal to 3.6 degrees Fahrenheit, until the system water temperature is within the desired range. Optimum water quality parameters for larval yellow perch are pH between 7 and 8, ammonia levels at 0 milligrams per liter, and temperature between 20 to 22 degrees Celsius, which is the same as 68 to 72 degrees Fahrenheit.